Hello everyone, welcome back to my channel. Today we'll be starting a new series on computer graphics, but we'll be talking about the hardware level computer graphics and not the software level version, which means that we'll be talking about the raster graphics version and not the vector graphics version, which you usually see in the softwares like Adobe Illustrator and AutoCAD and Photoshop. So this is the graphics that we are talking about is implemented in our computer hardware, and this is usually like all this that you see in the computer screen. It's actually these are the algorithms that are used to actually implement these graphics. And as you can see, when you look into detail in a computer screen, you can see that everything is represented as pixels, and there is a gap between each line. Each line is never continuous. It's not like vector. It's always it's like this version is called raster graphics because it's analog. It's discrete. It's like it's not continuously, every line is not continuously drawn. It's drawn as pixels. Alright, so the most basic algorithm that we use is the midpoint line drawing algorithm. With this, we draw every sort of line, every sort of things that's like a square or triangle or any sort of things that are not circular in general. There is also a midpoint circle drawing algorithm, but we'll come to that next. We'll come to that later on. Alright, so the first thing that you should know is that there are like 8 zones in every axis that the midpoint line drawing. Think of the whole computer screen as a grid, as a XY grid, and it's like there are coordinates and there are you can draw the lines. You can only draw lines and not curves for now. So there are 8 zones, and this is how the zones start: 0, 1, 2, 3, 4, 5, 6, 7. So this is zone 0, and this axis, zone 0 and 1, x-axis and y-axis have positive values. In zone 2 and 3, y-axis is positive and x is negative. In zone 4, 5, y is negative and x is negative. And with zone 6 and 7, both x and y, x is positive and y is negative. Alright, so within this negative axis, then there is the dx and dy. So when dx is greater than dy, then the point lies in zone 0. When dy is greater than dx, that time the point lies in zone 1. And as you can see, you can just remember this by the fact that dy, that means this is closer to the y-axis, so that's why dy is greater than dx. This is closer to the x-axis, that's why dx is greater than dy. Alright, so the first question that everyone would want is draw the first 10 pixels of a line. Before going to that, let me just show you how actually the graphics looks. So as you can see, a line is always drawn like in this format, and this is the grid system, box, that stuff that you see. This is the grid system of a computer screen, and these are the pixels. Now everything is always drawn by joining the pixels. Now if the pixels are perfect, like going through each of these dots, then your line is like perfect. But then not all the time the case will be like this. So whenever the case is like this, like it's going in between the pixels and sometimes outside the pixels, then you choose that's why this algorithm is called midpoint line drawing algorithm, because you first choose the midpoint, and if the pixel is closer to the if the distance between the midpoint and the other pixel, there are 2 pixels in between two pixels have 1 midpoint, and if the pixel is closer to the other point, then we choose this area to approximate the whole line. And if the line is closer to this point, then we use this point and to approximate the line, and we join it through this pixel. Now a line is actually not drawn in this format. Every line has to go through a pixel. So in order to decide which pixel to choose, we always choose the pixel that's nearest to that point. So since this pixel is nearest, we choose this point. Now this is all theoretical. This is that we can see with the eye, but then how do we make the computer understand? Of course, there's an algorithm for it, and that's why this is the midpoint line, or the Bresenham's line drawing algorithm that we use to determine which pixel to choose when going through a line. Because obviously a line cannot go outside a pixel; it has to be within a pixel. And we don't notice this difference mainly because it's so minute, it's so tiny that you won't even notice that everything that we are seeing in the computer screen is actually with the joining of this pixel, and they're not actually properly accurate. But since they're so tiny, you can't see the whole mistake, or the whole approximation of these lines. Alright, so let's go to the algorithm. The first question that will come is draw the first 10 pixels of a line from -3, 7 to 20, 70. Alright, so for the first step to do is, first you have to find dx. So dx is obviously 20 minus -3, so 20 minus -3, which will be 23, and dy, which is 70 minus 7 equals 63. So both are positive, so they're either in zone 0 or zone 1, and since dy is greater than dx, it is in zone 1, so we choose zone 1. Zone 1, this is north, south, west, east. So zone 1, and this is northeast. The general equation for a line is ax plus by plus c. Alright, now let's come to this part of the drawing. So since we're choosing zone 1 here in this case, therefore we have to draw this zone 1 representation over here. I had to delete that version because that was for zone 0. So since we're working with zone 1, we have to draw a small version of it here. Why? Because we have to derive the necessary equations for del NE, del N, and D decision variable, which is D initial. This is part of the algorithm. Alright, so as you can see, this is north, this is northeast. So the to find del N, what we do is we subtract the function of fm1 minus fm. fm1 is this and fm is this. So this is the change that's happening. Sorry for my approximation, but if you join these lines, this is the midpoint. This m is the midpoint of n and ne. We draw another part here, and here the midpoint of these part is m1, and the midpoint of these two parts is m2. Alright, so let's write the equation. So the first thing is, what is m? Let's write down here. M is, like, think of it as the coordinate system, the xy coordinate system. So m is x plus half and y plus 1. So x plus half, this is the coordinate, and y plus 1. m1 is x plus half and y plus 2. m2 is x plus 3 by 2, y plus 2. Alright, so fm1 minus fm. So fm1, as this f is the general function equation, which is this. So a, we just plug in the values. So a, x plus half plus b, y plus y plus 2 plus c minus a, x plus m, for m is x plus half plus b, y plus 1 plus c. So after doing arithmetic, ax and ax plus half and ax plus half gets cancelled, c and c gets cancelled, and only thing that's left is by plus 2 and by plus 1. So by plus 2b minus by plus b, by minus b. So sorry for the mistake there. So minus by, minus by minus b. So this gets cancelled. So what we have is 2b, b. Alright, so b is essentially dy. Alright, so we write dx. So minus dx, and we round it off and multiply it with 2 to get a whole number, a proper whole number. So 2 minus dx, which is essentially minus 2 dx. Alright, so next we move on to del NE. For del NE we get fm2 minus fm. So we get the same equation, we just plug in the values. So a x plus 3 by 2 plus b y plus 2 plus c, and then minus a, just extend it here. Alright, so a x plus half plus b y plus 1 plus c. So we get, so c and c gets cancelled out, other things don't get cancelled, so we have to write the whole arithmetic. So ax plus 3a by 2 plus by plus 2b minus ax minus a by 2 minus by minus b. So by gets cancelled, ax gets cancelled, sorry, and what's left is, scroll down, so what's left is 3a by 2, which is 3a by 2 minus a by 2, so a plus b. So a is dy and b is minus dx. So when you multiply it with 2, you get 2 dy minus dx. Alright, now let's find the decision variable, the initial decision variable, which is d init. Let me just erase this all down. So d init is just the midpoint. So a x plus half plus b y plus 1 plus c. So according to the general equation, ax plus by plus c will be equal to 0. So ax plus a by 2 plus by plus b plus c. So here ax plus by plus c will be 0. So what we are left with is a by 2 plus b, which is a equals to dy by 2 plus b is minus dx. Sorry, b is minus dx. So we get, when we multiply it with 2, we get dy minus 2 dx. Alright, so now let's get down to the calculation. We will have x, y, the d value, and the direction, which is easier for us, which is just for keeping track of the calculation. We know dy, we know that del n, del n equals minus 2 dx, and del ne equals 2 dy minus dx, as we have derived. So the first coordinate that we are given is minus 3 comma 7, as in the question. So when minus 3 comma 7 is given, we have to find del ne first, the value of del ne, which will never change in case of midpoint line drawing algorithm. So because we already found out dx and dy, so dx is 23, so 23 into 2 is minus 46, so we get minus 46 here, and del ne is 2 into 63 minus 23, so we get 80. So these values are going to stay constant, and these are going to be used for our calculation. So the first step to the calculation is, firstly you get the value that you have is minus 3, y is 7, and d is the decision variable, the first initial decision variable is dy is dy is 63 minus 2 into 23. So whatever the dy value is our first decision variable. So let me just check the answer here. First decision variable dy is 17. Alright, so 17. So now we have to find out which direction is positive and negative. Now in this case, let's just assume that this part over here is dy does not change, the height does not change, so dy will be 1 because the thingy is pointing upwards. This is pointing upwards, the value is positive. And dne, for this the value is 0.2, let's assume, and for this the value is, suppose let's take an arbitrary point here and here. For this the value is 0.2 and for this the value is 0.8. Suppose it can be 0.3, 0.7 or it should be something that's less than 0.5 and something that's greater than 0.5 to determine which point is closer to which. So it has to be something very less than 0.5 so that we could know that point should belong to n, and it should be something very like greater than 0.5 so that we could essentially take that point to be closer to ne. So now plugging in these values in the d initial function, so we get dy minus 2 dx. So dy is 1 minus, let me just clear this up here. So to determine which one is positive and negative, for n we write d equals, so dy is 1 minus 2 into dx. So 2 dx is, for n the dx is 0.2, so into 0.2, which will be some positive value. And when d equals 1 minus 2 into 0.8, it will be some negative value. So this is negative value for ne direction. Negative value, why? Because 1 minus 2 into 0.8 is 1 minus 1.6, so it's minus 0.6, and 1 minus 0.4 is 0.4. So it's a positive value, it's a negative value. So we take n as positive and ne as negative. Alright, so since d is a positive value, with the direction that we're choosing is n. Alright, and then after that, what we do is, since the direction is n, now we just add d init. So d equals d init plus del, since it's n, so del n. So 17 plus the value of del n that we found out is minus 46. So minus 46. So we get, just too lazy to calculate, we get minus 29. Minus 29. Alright, so minus 29 is a negative value, which means it's in the northeast direction. So again, we just add with this d, we add this right here. With this d, we add minus 29 plus del ne, which is minus 29 plus 80. So we get we get 51. Now these things you can fill up later, but it's easier if you fill it if it will be better if you fill it up as you go. So since it's a north direction, in north direction what happens is the y value only increases, y plus plus, but in northeast value y also increases, x also increases. This is for north, this is for northeast. So in north direction only y value increases, so 8, and this will be minus 3. In northeast direction y and x both increases, so minus 2, 9. And since this is positive, we know when it's positive it's n, so we choose n. Again we add 51 plus 51 minus 46, we get 5, and we increase, since it's a north direction, so we increment only the y, so 10 and minus 2, and since this is positive, we're choosing n again, and then after that we again add 5 minus 46, so we get a negative value, which is minus 41. And since it's n only y is incremented and x remains the same. So if you want to check your answers to this question to find the first 10 pixel coordinates, you can pause the video and you can just jot down these answers and then continue doing this with the algorithm I've been using, with the method I've been using, and then check your answers accordingly. And so that's about it for midpoint line drawing algorithm. If you get any questions with the coordinates that's given to you, all you do, the first step that you do is you find the dx value, the dy value, then you find the zone, whichever, depending on whichever is positive or negative, and whichever is what you call it. Since you have to always take the magnitude, by the way. First you determine according to the signs. If it's negative, according to the sign, you determine if it's in which zone it is. After that, to determine within these two zones, whichever one you have to pick, you have to do it by the magnitude of dy and dx. All right. So if the magnitude of dy is greater than dx, it's in this zone, and the magnitude of dx is greater than dy, then it's in this zone. All right. So next, then after that, what you have to do is you have to derive the necessary equations. So if it's on zone, suppose if it's on zone 0, it will be northeast and east, and you have to find out the midpoints for each. So think of it as a coordinate system, and you find the midpoint. So x plus 1 for northeast and east, it will be, suppose the midpoint is here, so x plus 1, y plus half, and the midpoint 1 is here, so x plus 1, x plus 2, y plus 3 by 2, and again another midpoint is here, so x plus 1, y plus half. Alright, and then after that you plug in the values to fm1 minus m. If you like rewind the video, and you can see the functions that I've been using, fm1 minus m or fm2 minus m, and then you plug in the values in the general equation, and then you derive these parts, which you will then add to your d initial value. Then you find the d initial value by plugging in the values, plugging in the the x plus the coordinate values, and then finding out the equation, deriving the equation. And after that, after deriving d init, del n, del ne, or there will be two directions all the time, so d init, del s, del se, or d init, del del nw and del n, you get obviously then plug in the values, and then find out, using the algorithm, you find out the necessary coordinates and the decision variable. So that's about it for Bresenham's line drawing algorithm. I hope that was clear enough. If you don't find it clear enough, I hope that if you could watch it the second time, then you would understand. And also, please keep the algorithm in front of you so that you could know that your method is actually correct. And if you want to see the values again, pause this video and see if your answer matches by using the method I used. And so yeah, that's about it for today. I'll see you in the next video. Thank you.